Good day. This supplementary presentation is titled Beyond the Paper, Validating Ojerudi's Theory. The goal here is straightforward. The original theory proposes that electromagnetic consciousness states can emerge as stable solutions of a coupled field system. This presentation focuses on validation, meaning what is solved, where it is solved, what emerges, and how it becomes measurable. In other words, it is not another statement of the theory. It is a guided demonstration that the theory can be made concrete and testable. The question is, how can an EMC state emerge in a brain-like medium? Ojerudi's framework claims that consciousness is not added as an assumption, it is identified with a regime of the coupled dynamics. Coherent electromagnetic organization, non-abelian information alignment, and mediator-driven stability. So from the beginning, the validation strategy is: define the physical domain, solve the coupled equations, demonstrate that coupling changes the electromagnetic behavior in a specific way, show that the new behavior has stability and measurable signatures. The first thing this presentation validates is that the model is not living in an abstract box. It is implemented in a voxelized head domain, with anatomically meaningful regions, air, scalp, skull, CSF and ventricles, gray matter, and white matter. That matters because coherence is always shaped by geometry and material boundaries. So this slide establishes the first point: the theory is implemented in a realistic computational anatomy, not an idealized toy model. With the geometry set, the next step is to clarify the field architecture. This is the heart of the framework: three coupled components. The U1 electromagnetic field. This is the physical field that can ultimately be detected through EEG and MEG. The SU2 information gauge field, representing internal structured coordination, not an electrical signal but an organizational degree of freedom. And the mediator scalar field, which controls nonlinear coupling strength and provides the stabilizing background. This slide is important because it makes the conceptual claim explicit. The electromagnetic field is not alone, it is dressed by internal information dynamics and stabilized through a mediator. Now the presentation moves from concept to mechanism. The validation step here is simply: these are not illustrative metaphors, they are governing equations that are solved in 3 dimensions. Addressed Maxwell-type equation, a Yang-Mills equation for SU2, and a nonlinear mediator equation. At this point, the claim being tested becomes very concrete. Do these coupled equations produce coherent, stable field states in brain-like geometry? This is where the argument becomes visible. The left panel shows an electromagnetic regime with no coupling. It is smooth, largely symmetric, and dispersive. That is exactly what one expects from classical propagation in a lossy medium. The right panel shows what changes when the dressing is activated, coupling to SU2 and the mediator. Now the electromagnetic field becomes structured and anisotropic, with a much more coherence-focused spatial organization. This slide validates a central physical point. The coupled theory predicts a qualitative change in EM behavior, not just a small perturbation. If the electromagnetic field changes, the next validation question is: what is the SU2 field actually doing? This slide shows that the SU2 field is not noise. It forms organized, vortex-like structure, with directional alignment that correlates with coherence regions in the EM field. So the SU2 sector is doing something specific. It provides an internal, structured degree of freedom that can support global coordination. That supports the interpretation of SU2 as an information field in the precise sense intended by the framework. Even if structure appears, the next validation step is stability. Many models can produce transient organization, the real challenge is persistence. This slide shows exactly that. At low coupling, the mediator is broad and diffuse, and EMC states are unstable or short-lived. At high coupling, the mediator forms localized energy wells and sharp gradients, effectively trapping and stabilizing coherent configurations. This provides the stability mechanism the theory requires. It explains why EMC states can behave like robust dynamical regimes rather than fragile patterns. Now the previous pieces come together. The slide shows an EMC snapshot where electromagnetic magnitude, used as a coherence proxy, is aligned with SU2 directional structure. This is important because it turns the definition into something visual and checkable. An EMC state is not merely high EM power. It is spatiotemporal coherence with aligned EM and SU2 organization. So at this stage, the presentation has validated geometry, field architecture, equations, qualitative EM change, SU2 structure, and mediator-driven stability. Next comes time evolution. If EMC is a genuine state, it should emerge through a recognizable dynamical transition. This plot shows three regimes: a low, noisy pre-EMC regime, a transition regime with rapid growth of coherence coupling, and a stable EMC regime with a plateau. That plateau matters. It indicates that the system is not continuously drifting, it reaches a stable attractor-like regime. This slide reinforces the time story with a spatial story. Before EMC, the field has weak structure. During onset, coherence begins locally and organizes. In the stable state, coherence becomes persistent and clearly structured. So the argument is now consistent in both dimensions. EMC is a spatiotemporally coherent field regime, not a momentary visual artifact. At this point, the validation must meet a practical requirement: observability. The model produces measurable predictions by projecting the dressed electromagnetic potential to scalp sensors. And what appears is recognizably EEG/MEG-like, multi-channel oscillatory traces, coherence networks, and frequency-dependent structure. This is a key bridge: field theory observable signals. This slide answers that question directly. The butterfly plot shows realistic temporal texture, alpha rhythm components, faster components, and coherent relationships between channels. For an experimental neuroscientist, this is an important credibility checkpoint. The model is not only mathematically consistent, it produces signals that sit in the right phenomenological space. Here the presentation provides what reviewers typically expect next: spectral peaks in canonical bands, coherent spectra between sensors, and coherence matrices in the alpha band. These are not decorative, they formalize the claim that the EMC regime produces enhanced long-range synchronization and structured functional connectivity. The final validation step is robustness. If EMC depends on extremely precise tuning, it is not compelling. This slide shows that as coupling increases, the EMC measure exhibits a low coupling incoherent regime, a sharp transition near a critical value, and a high coupling saturation regime. That is the signature of a phase-like transition, not arbitrary tuning. It supports the idea that EMC is a genuine dynamical regime of the coupled system. Conclude, this presentation validates the theory on multiple layers, step by step. It is implemented in a realistic head geometry. The full coupled equations are solved. Coupling produces a qualitative and interpretable change in EM organization. SU2 shows structured dynamics rather than noise. The mediator provides stability. Coherence emerges in time and space as a stable regime. The model produces EEG/MEG-like signals with the expected spectral and coherence properties. And EMC behavior demonstrates phase transition-like robustness with respect to coupling. That combination, geometry, dynamics, stability, and observability, is exactly what turns a theoretical framework into a testable scientific proposal.